All right, this is section 4.4 called Simplifying Fractions. And, well, we'll just get started. First, we'll start off with a review. Remember, I'm sure we all remember what a fraction is. Remember the numerator. Oops, sorry. The numerator is at the top. And that is over the denominator. You can kind of fit it in there. Yeah, that's basically our review. The fraction is where we have a number on the top, number on the bottom, numerator and denominator. Equivalent fractions describe the same part of the whole. What that means is if I have 3/4, let's say I multiply the top by 3, the bottom by 3, I would get 9/12. And essentially, that means the same thing. Let me try and explain it in a different way. Let's do 1/4 and times 2 and 2/8. Okay, so let's say I have a pie. I cut it into 4 pieces. And remember, this is not going to be exact because, well, I'm writing on a little iPad. Okay, so, but if this was actually literal, so 1/4 would be this one piece of the pie. Okay, now let's say I cut that same pie into eighths. 1, 2, 3, 4. I'm going to make that a different color so you can easily see it. So here are my eighths pieces. I have 1, 2, 3, 4, 5, 6, 7. Now I have 8 pieces. And you'll see that those 2 pieces are the same as the 1 piece when it was cut into 4 pieces. Okay, so it means exactly the same thing. They are just the same part of the whole. So equivalent fractions is when we multiply the numerator and the denominator by the same number, or we divide the numerator and denominator by the same number. They get us equivalent fractions. All right, so let's do some examples. Our directions say find 2 equivalent fractions. First one we're going to do is of 5/15. Okay, so like I said before, one option is I can multiply them both by, let's say, 2. So then I would get 10/30. So here's one of my equivalent fractions. And then let's take 5/15 and divide them both by 5. Okay, so I've got 5/15 divided by 5, so I would get 5 divided by 5 is 1. 15 divided by 5 is 3. So 1/3 is an equivalent fraction, 10/30 is an equivalent fraction to 5/15. Okay, let's try another one. Let's try 10/12. I see I can divide them both by 2. So I would get 5/6. Then I could also take 10/12 and multiply them, the numerator and denominator, both by 2. So I'd get 20/24. So here are my equivalent fractions. Make sure that, listen carefully, I'm not going to say this again. Well, I probably will, but make sure you're showing me this. This right here. I know a lot of times you're like, well, how do I show my work? Because I'm doing it in my head. This is your work. You showing me what you're multiplying and dividing by so that I can easily see. Because sometime you might accidentally multiply wrong, but if I can see that you meant to multiply it by 2, but you accidentally added 2, then I can know what's going on in your head. Whereas if you just write down random numbers, I have no idea how you got there. So that's why I need to see this part right here as your work. All right, so let's try one more. 14/20. So I see I can divide them both by 2. Okay, so I would get 7/10. Or I could take 14/20, multiply them by 2. Again, you can pick any number. I'm just picking 2 because I can do it quickly in my head. I know 14 times 2 is 28. 20 times 2 is 40. I can do that in my head. But you could pick 30 if you wanted to. You could pick 100 if you wanted to. As long as you're multiplying and dividing the numerator and denominator by the same number, that's okay. But really, if we're dividing, though, we want to make sure that it's going to go in there evenly. Like I wouldn't want to divide 14 by 5 because 14 doesn't go into 5. Okay, so that's what we do to find equivalent fractions. Multiply or divide the numerator and denominator by the same number. Okay, so here we're going to talk about simplest form or reduced form. And that is when the numerator and denominator have a greatest common factor of 1. So let's do a couple examples of this. The first one we're going to do is we are going to do 6/8. Okay, so I know 2 goes into both of them. So I would get 3/4. So our greatest common factor between the two is 1, so 3/4 is our answer. That is in simplest form. There is no other number I could divide 3 and 4 by that would get it to be a smaller number. Let's try another one. Number 2 says 9/12. Okay, looking at this number, I see 3 goes into both of them. So I can divide by 3, and I would get 3/4. Again, simplest form because the greatest common factor between 3 and 4 is 1. All right, for number 3, it says 28/35. This one's a little trickier to see right away, but I do know that 7 goes into both of those numbers. Okay, so if I divide by 7, 7 goes into 28 4 times, and 7 goes into 35 5 times, so 4/5 is my simplest form. All right, let's try another one. 18/21. Looking at this, I see I can do 3, so I'm going to start with 3. I might be able to do more later, but I'm just going to start with 3. 18 divided by 3 is 6. 21 divided by 3 is 7. Whoop, that looks like it's going to do it. 6/7 would be our simplest form. So again, if you get something like, let's say we did, this is not an example you need to write in your book, but I just want to make a point here. Let's say you had 20/36, and you see you can divide both of them by 2. So let's go ahead and divide them by 2. 20 divided by 2 is 10. 36 divided by 2 is 18. I see I can go farther. 10/18 is not all the way as low as it can go because I can divide both of them still again by 2. So let's divide by 2, divide by 2. 10 divided by 2 is 5. 18 divided by 2 is 9. So 5/9 would be my simplest form. So sometimes you will have to do that more than once. You'll have to divide. This time I had to divide by 2, divide by 2. So sometimes you'll have to divide more than once. You won't just get to do it once and be done. So make sure that you get it as low as you possibly can. All right, so let's go on. Well, I'll say this quick. Remember, this is your work here. You need to show me what you're dividing them by. Because again, let's say you did 8 divided by 2 and you put 6. Then I would say 3/6. Well, that's not anywhere close. But if you tell me this divide by 2, then I can give you at least partial credit because I see what's going on in your head and what you were thinking to do, but then something else just came out on the paper. So that's why it's so important for you to show your work so that I can see what your thought process is. If you did -2, then I'd say, oh, gal, we better have you come in early or something so that we can talk about it. But if I see divided by 2, there's your answer, and your answer was wrong, but your work was right, I can still give you partial credit on that. All right, the next thing we're going to try is called reduce using prime factorization. And what we're going to do for this one, well, let's just do an example together. I have 6/8. Okay, this is kind of the way that we're going to start thinking about reducing. And you will use this a lot when you get into high school math, when you get into college math. You start thinking this way. So this is kind of our first step of reducing using prime factorization. So what I'm going to do is I can say to myself, I know that 6 is 2 times 3. Okay, so I got that down. And I know 8 is 2 times 2 times 2. Okay, so I've got 2 times 3 and 2 times 2 times 2. So a rule that is so nice and so easy for us to follow is if there's a number on the top and we're multiplying all these numbers. This doesn't work for addition or subtraction, but if we are multiplying numbers together and I see some on the top, some on the bottom, I can just cross them out. So I see I have a 2 on the top and a 2 on the bottom. So I get to cross 1, 2 off. I have to make sure that if I'm crossing 1 off on the bottom, I only cross 1 off on the top. I can't do 2 on the bottom, 1 on the top. It doesn't work that way. They have to evenly match up, and then I can take them out. So now I'm left with 3 for my numerator and 2 times 2 for my denominator. Okay, so now I have to solve that. So I would get 3, and 2 times 2 is 4. So here is how I'm going to simplify or reduce. I know you're going to think to yourself, well, Mrs. Hamer, that's dumb. Why would we do all these extra steps when I can know that 6/8 reduces down to 3/4? But the problem is we're going to start doing things that are much more complex. At the end of the year, you're going to be doing it in 8th grade, 9th grade, 10th grade, 11th grade, 12th grade, and it's going to be so complex, you're not going to be able to look at it and do it in your head. Okay, this is just kind of the baby steps along the way, where you said to yourself in kindergarten, well, why would I have to show that 1 plus 1 is 2? But when you get to 6th grade and you have to show that 357 plus 468, you can't do that in your head. You have to be able to know how to do those little steps along the way. So let's do another one for an example. This time we are going to do 26/39. Okay, follow me here. I know you probably wouldn't see this in your head right away, but I see that I can divide 26 by 2. So I'm going to do a little math over here. 26 divided by 2 goes in there once. Bring down my 6. 2 goes into 6 3 times. Okay, so it's times 13. 13 is a prime number. I can't times 2 by anything to get there, or 3 or 4 or 5 or 6 or 7 or 8. None of those numbers can multiply. So I know that 13 is a prime number, so I'm done. Okay, for number 3, we can use my divisibility factor. I can add up all the digits and see if that number is divisible by 3. So 9 plus 3 is 12. 12 is divisible by 3, so that means I can divide it by 3. 39 divided by 3, I would get 1. 3 goes into 9 3 times, so I would get 3 times 13. So this one is really, really handy because right away I can see I can cross off a 13, and I would get the answer of 2/3. Okay, so because there's a 13 on the top and a 13 on the bottom, I can cross it off. Now, hypothetically speaking, let's say there was a times 13 here. You're probably wondering to yourself, well, can I cross off that one? Remember, that is not how it works. I cannot cross off 2 on the top and only 1 on the bottom. It has to be the same on the top and the bottom. So let's look at the next one, number 3. Oops, better get my pen out. Number 3 says 8/12. Okay, so I know I can divide it by 2. 2 times 2 is 4. 4 times 2 is 8. So 2 times 2 times 2 is 8. Okay, so let's figure out 12. 2 times 2 is 4. And 4 times what's going to get me to 12? 4 times 3. Okay, so now I get to do my crossy-offies, and I get to say, okay, there's a 2 on the top, 2 on the bottom. 2 on the top, 2 on the bottom. Now that is where we need to stop. because I do have another 2 on the top, but I don't have another 2 on for the denominator. Okay, so my answer will be 2/3. So this is the kind of technique we will also be using when we are reducing when we have variables, which is what we're going to do next. Okay, so now we have simplifying with variables. Now this is something completely new. We have never done this before, so please listen very carefully. If there's anything you don't understand, please feel free to watch it again. And really what I recommend you guys to do is if you watch it and you're writing it in your notebook and then you think back and you're like, wait a minute, what did she just do here? Then you should just scroll back on the video and just watch. Don't worry about writing into your notebook. Don't worry about taking notes. Don't worry about anything like that. Just watch. That's all I want you to do so that you can really take in what I'm saying. You can really listen and follow along very closely. All right, so the first one we're going to do for this, I'm thinking I'm going to do a peach color. That looks like a nice color. Okay, so the first one we're going to do is P over 2P. Okay, so I see that I've got P on top, 2 times P on bottom. So that means I can cross off a P, cross off a P. Here, I'll do that in a different color. I can cross them off because there's a P on the top and a P on the bottom. So now you're going to ask yourself, though, but wait a minute, there's 0 on top because I have nothing left on top. But we can't have a 0 on top. So because I crossed off that 1, listen here, whenever we just have a P, really imaginarily, in front of that P, there's a 1. Because we have 1 P up there. Okay, so if I cross off the P, I'm still left with that 1. So now I'm left with 1/2 for my answer. So I want to say that again. Whenever, like for my example, I had P over 2P. When I just have a variable by itself, there's no number in front of it, really there's always a 1 in front of that number. So don't get mixed up and write 0 over 2 because you crossed off the P and now there's nothing there. That is not right because there is that 1 there and don't forget about it. Okay, let's try one that's a little bit trickier. Number 2 says x squared yz cubed over x y z squared. Okay, I'm going to put a little line through there. That's the problem with using z's is they sometimes do look like 2's. So if you're writing a z, I'd appreciate it if you put a little line through the middle so I know it's a z and not a 2. So now we have to prime factorize here, guys. So I have x times y times z times z times z all over x times y times z. Oops, I forgot my C. Look at that. I'm already forgetting. Times z. 2 z's on the bottom. Okay, now I have to go through and cross off the ones that are the same. I have an x and an x. A y and a y. Z, 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 z. So now I have to go back and go through and see what I have left. On the top, I have x, z. On the bottom, what do I have, you guys? Do I have a 0? I don't have a 0. I have a 1 because remember, in front of all of these numbers was a 1. So I have it over 1. And just like I'm not going to write 7 over 1 to write the number 7, I don't have to use that one. I can just write my answer as xz. Okay, we can just drop the over 1 because it doesn't change anything. It's just over 1. That's all it is. So my answer would be xz. Okay, let's try another one. 24x squared y over 8xy. Okay, remember we have to prime factorize even our numbers. So for 24, I can do 2 times 2 would be 4 times 2 would be 8. So 8 times what's going to get me to 24? 8 times 3. So let's double check. Always double check this to make sure you got it right. 2 times 2, sorry. 2 times 2 is 4. 4 times 2 is 8. And 8 times 3 is 24. So we got our 24 down. Then I need to multiply times x times y. All over 8. We know 8 is just 3 2's. Times x times y. Okay, now I just got to go through and cross out. Da, da, da. Cross off an x, cross off a y. So I am left with 3x on the top. On the bottom, I'm left with nothing. But remember, I don't have to put over 1. I can just leave it because I know it's over 1 anyways. So there would be my answer, 3x. Okay, we're going to try one more here. I'm going to try to fit it. Well, I suppose I can move this all up here. Okay, so last one we're going to try together is 3ab squared over 12ac. So what I'm going to get is 3 times a times b all over. Okay, 12. Let's see. 2 times 2 is 4. And 4 times 3 gets me to 12 times a times c. Okay, let's go through and cross off what we can. Cross off a 3, cross off a 3. Cross off an a, cross off an a. So on the numerator, I'm left with b times b. On the denominator, I'm left with 2 times c. Okay, so now I have to think about it. B times b, that's really b squared, because there's 2 b's. I have my base b, and then there's 2 of them, so then I do squared. Okay, and then on 2 times 2 is 4. C on the bottom. So my answer is b squared over 4c. I want to I want to remind you there is a quiz after this section. So it would be very wise of you to study for this quiz and come in tomorrow morning with any questions you might have. Okay, because I feel like right now we're waiting until after the quiz and say, oh shoot, we didn't do well on the quiz. Well, that doesn't help us. We need to get help before we take the quiz and not wait until after we take the quiz, because then our quiz grade is not so great. Okay, so if there is any questions you're having on anything, please be sure to come see me before your quiz. All right, I'm going to go through a couple questions on your homework. So if you do not have any questions, then you can stop watching the video after you take your quiz. Your video quiz, not your quiz that you're going to be taking after this section. So keep watching if that is you want a little extra help. Okay, let's start. Find 2 fractions equivalent to each fraction. I think we know enough about equivalent fractions that right now I'm not going to do an example from 1 through 6. Write in simplest form. All right, I suppose I can do one of these. Okay, so it says number 8, says 4/10. So I can divide the top by 2, divide the bottom by 2, and get 2/5, which would be my answer, 2/5. Okay, so that's the only one I'm going to show you for that section. Number 14, let's do that one. 14 says 2x divided by 3x. So if I write it using prime factorization, I would write 2 times x over 3 times x. I can cross off the x's, so I'm left with 2/3 for an answer. I'm going to do 15, because 15 looks a little bit more tricky than most of them, okay? So let's do 15. I know you don't have to do it for your homework, but it is a good little review. So I have 4km squared over 12k. Okay, so I have to remember, I have to prime factorize the numbers. So for 4, I would do 2 times k times m, all over 2 times 2, which is 4, and 4 times 3 makes 12 times k. Okay, so now I go through 2, 2, 2, 2, k. So I would be left with m times m, or m squared on the top, and 3 on the bottom. So that's what we should be getting for number 15. All right, then number 22 through 27. Again, you just have to find two equivalent fractions. Number 28 through 39. I think I'll pick number... Let's do this one. Let's do number 32. Okay, so it says 15 to the third power over 15 to the second power. Okay, so let's do 15 times 15 times 15 all over 15 times 15. Okay, so I can again go through and say what is the same on the bottom and the top. So you have 15, 15, a 15, 15, and I am left with a 15 on the numerator, so our answer is just plain old 15. I think I'll do 34 as well. 34 says 5c squared d divided by, over 15c. So now I have to write it out. 5 I can't prime factorize because 5 is a prime number. 5 times c times d all over 15. I can do 3 times 5 times c. Now I can go through and cross off. I have two 5s. There you go. A C and a C, but that looks like it. So on the top I have CD, and on the bottom I just have a plain old 3. So here's my answer. Alright, I think that is all I am going to do for this homework. So again, if you have any questions, please feel free to ask. And if not, I will see you tomorrow. Thank you for watching.